Okay, guys, here we go. We're going to go through a problem of horizontally thrown projectile problem. Pretty simple problem here. But as always, with all of our problems, the first thing to do is to draw a picture. So here we got a student Joe is going to throw a ball off a cliff horizontally. The cliff is 45 meters high. So here's my cliff. There's the cliff. And the cliff is 45 meters above the ground. And then here's the ground. So here's the cliff. And here's the ground. There's a simple picture. Now this ball is going to be thrown horizontally, not that way. It's going to be thrown horizontally with a speed of 12 meters per second. We're going to, very, very important that air resistance is negligible. So it's got that speed, that's it. We want to know how far away it's going to land. We pretty much know what this ball is going to do already. We know the ball is going to take some path. It's going to follow a parabolic path, something like that. But we need to know what the range of this ball will be. How far will it go? The range is in the x direction. What's the x direction? Range. X direction. And how long is it going to be in the air? Well, that's another interesting question. We're going to use the y direction to figure that out. And then how fast will it be when it strikes this one? We have to combine x and y. Because when it hits the ground, it'll be moving down and sideways at the same time. So we'll have to combine them. But here we go. So basically, you're going to take your very favorite kinematics equations, the favorite kinematics equation, d equals VIT plus 1/2 AT squared. But now you're going to split it. You're going to make everything vertical and everything horizontal. So you're going to get your change in position in the y equals your initial velocity in the y multiplied by time plus 1/2 your acceleration in the y direction multiplied by time squared. And you're also going to then repeat that equation in the x direction. Change in distance in the x, the change in position in the x, is going to be your initial velocity in the x multiplied by the time times VIT plus 1/2, write it correctly, 1/2 the acceleration in the x direction multiplied by time squared. Okay, something that's really, really important. When the ball is over here, or any place in its path, as long as we're neglecting air resistance, the only force acting on it is gravity. Its velocity will be this path. But the only force acting on it is gravity. So there is no x direction acceleration. So that all goes to 0. That's really, really useful. So in the y direction, in the x direction, it's just initial velocity multiplied by time. The other thing that's really cool is that its initial velocity is only sideways. Its initial velocity in the y direction is 0. It has no initial velocity in the y direction. So in the y direction, you get this. And since it's only accelerating due to gravity, the acceleration in the y direction is 9.8. So let's do some math. This thing is going to lose 45 meters. 1/2. It's going to accelerate negative 9.8 meters per second squared due to gravity. times t squared. Well, this isn't difficult math now at all. Now it's just solving for time. This thing is going to be in the air just about 3 seconds. Negative 45 meters equals negative 4.9 meters per second squared equals multiplied by t squared. 45 divided by 4.9 equals 9.18 seconds squared equals t squared. Square root of both sides. 3.03 seconds. We get t equals 3 seconds. Well, that's super, super useful to come over here. How long is the ball going to be in the air? 3 seconds. How far away will it land? Once you have that, now you just come into here. All right. Pretty easy. Change in position of the x. Its initial velocity was 12 meters per second. It's going to be in the air for 3 seconds. 36 meters. The range, this spot there, will be 36 meters from the base of the cliff. My picture is not to scale. That's why it should be someplace over here. Okay, so it's only going 36 meters sideways, but it falls 45 meters that way. And it's in the air for 3 seconds. Very important. Have 36 meters. Now, how fast will it be moving? When it is in the air, the ball is here, it's going 12. The ball's over here, it's going 12. And the ball's over here, it's going sideways. Sideways is always 12 meters per second. 12 meters per second. 12 meters per second. 12 meters per second. Because the acceleration of the x is 0. There's no force acting on it sideways, so it doesn't accelerate sideways. It keeps the same speed. But that is not true vertically. It does gain speed. When it gets over here, it's going almost 0, but then it's got a little bit. When it's over here, it's going to be going a little faster. Gravity will accelerate it downward. And when it hits there, it's going to have the greatest downward velocity. So it should have the greatest downward length arrow there. A little bit there. What will the speed be? What will the downward speed be when it hits the ground? Vf equals Vi plus At. It had, again, just like this, we can separate this into Y. The Vf in the Y, the final Y velocity, the x velocity is just 12. The final y velocity will be the initial y velocity plus the acceleration in the y direction multiplied by time. The final y velocity is what we want. The initial y velocity was 0. It had none. 0 plus negative, this should be negative 9.8 meters per second squared times 3 seconds. Just about 29.4 meters per second. 29.4 meters per second, and that's downward. Whoop. 29.4 meters per second. And it's got a sideways velocity of 12. So now we got to combine those. They're at right angles to each other. How do we combine a sideways velocity of 12 and a vertical velocity of 29.4? That should be easy. Both are vectors, 12 meters per second that way, and 29.4 meters per second that way. The resulting velocity vector is there. The resulting velocity vector is there. You got to use Pythagorean. 12 meters per second squared plus 29.4 meters per second squared. Take all the square root of that. Equals R. 12 squared plus 29.4 squared equals that. Take the square root of that mess. The resulting velocity is 31.8 meters per second squared at the angle. And you could then figure out the angle. The angle here, what is this angle going to be? 29.4 divided by 12. Arctan of that, or invert tan, however you want to call it. That would be 68 degrees. At 68 degrees below the horizontal. I was going to say south of something, but I really should say below horizontal. Right? That angle right there is 68 degrees. Tan theta equals 29.4 meters per second over 12 meters per second. You get theta to be 68 degrees. And how fast will it be moving when it strikes the ground? 31.8 meters per second is just the speed, not the velocity. 31.8 meters per second. And down at that angle. It's going to be moving some sideways and some vertical. That is it. Simple problem.